Working Energy 4.3 Conservation of Energy Notes. All right, the law of conservation of energy states that energy cannot be created or destroyed, and that the energy in the universe stays constant. Okay, pretty cool picture here. Somebody sitting looking at the universe, and you can see the energy is constant. Energy is constantly recycling. All right. So, in my own personal interest, my own personal way, um, ghost hunting. Ghost hunting. If we could talk about ghost hunting for a second, we could say that human beings are nothing but energy. We're energy. And because we're energy, we I'm thinking, I'm sorry. Human beings are energy. If energy cannot be created, destroyed, when a person passes away, when there's energy, that energy is left. And that's what ghost hunters are looking for, energy. If you watch any of that ghost hunting stuff on TV or any of that, they're always trying to pick up energy. Energy. And that's what I'm looking for when I ghost hunt. I'm looking for energy of since it can't be created or destroyed, it has to go someplace. And here is a little video
This was where the physical stuff
on
happened.
ghost hunting
Being scratched, being touched,
and looking for energy.
Wow. And growls.
Well, let's go get our equipment. I say we set up in here. We took 2 bone chisels that were found on the property during renovation and then plugged them into our proximity sensor. Basically, if anything tries to reach and grab those, it lights up and lets us know, hey, something's going on here. And we were just trying to do anything we could to document whatever is there.
I'd like it if you try to grab those tools.
Holy crap! Well, that's the proximity sensor. That's around those tools. Well, the energy has changed and it's fluctuating. You see a blink? It just blinked.
Mm-hmm.
So what the hell's going on in there? What's that?
If you didn't see it, watch. I'll point it out with the cursor
What the
here.
hell's going on in there?
The proximity sensor is flashing down there, and as it's flashing, an orb goes by the doorway. Right there. Comes through. Take a look again. It's going to go right through there.
And it's fluctuating. You see a blink? It just blinked.
Mm-hmm.
So what the hell's going on in there?
Right there.
What's that?
One more time.
You see a blink? It just blinked.
Mm-hmm.
So what the hell's going on in there? What's that?
I just thought I saw something right there.
So that's what we look for. We look for those kind of things when we're ghost hunting, and that was dandy. That was dandy. All right, conserving resources. Think, act, and save. Now, look, when we talk about conserving resources, we're talking about saving energy. You know, think about leaving on extra lights, turn them off, and help save the planet. But in science, the conservation of energy is a little bit different. Energy cannot be created or destroyed, but it can be transferred. And this is what our homework is about right here. So make sure you're paying attention to this. Chemical energy, the chemical bonds in this ice cream cone give this person the energy for motion. So it transfers chemical to motion. Energy, chemical energy to the energy of motion or kinetic energy. Here's radiant energy from the sun. It turns into chemical energy in the plants and in the trees. Chemical energy in the gasoline turns into the kinetic energy of motion. Electrical energy turns into thermal energy. It transforms from one to another, one type to another, but it's always conserved. Okay? It's always conserved. So the energy in this ice cream cone, This person riding this bike gets the energy and uses it to move. Okay. Energy is always conserved. Mechanical energy. Mechanical energy is the total of the kinetic and potential energy. Now we know gravitational potential energy, when this roller coaster is at the top, it has high potential energy. It has high potential energy because of the height. Gravitational potential energy, height times mass times gravity. Okay. As it loses height, as the cart loses height, kinetic energy goes up. The kinetic energy starts to go up. And you'll want to watch the lecture because I will illustrate this for you. Potential energy is going down. So if I'm at 100% or 100 potential energy here, as it starts to come down, when it's halfway, 50 kinetic, 50 potential. As it gets to the bottom here, the bottom of the track, the kinetic energy is very high and potential energy is going to be low because I've lost height. All right. Mechanical energy is the total of the potential and kinetic added together. Again, this apple in the tree, this one here has high potential energy, high gravitational potential energy. When it breaks off and it starts to fall, as it falls, it loses gravitational potential energy, but gains kinetic energy. As it goes and it hits the ground, high kinetic energy, low potential energy. After it hits the ground, you'll think, well, what happened to the energy? If it lost its energy, but it doesn't. That kinetic energy, as the apple hits the ground, turns into sound energy. All right. It'll turn into sound energy, and there's a little bit of energy that is pushed into the ground or transferred to the ground. And then most of it, though, is going to be sound energy. Projectile motion, again, right here. Low potential. As the guy kicks the ball, kinetic energy is increasing. As the ball climbs, kinetic energy decreases. Potential energy takes over. When it's right here before it starts to fall, its highest potential energy, and it slows down, lowest kinetic energy. As it comes back down, as it goes back down, and we'll just look at it here. As it's coming down, it's losing gravitational potential energy, and it's going back to a high kinetic energy. So it goes from low potential, high kinetic. When it reaches its peak, notice it slows down, and as it starts to drop, it speeds back up. Projectile motion. All right, same thing in a swing. The highest point of the swing, high potential energy, no kinetic energy because it's going to stop. As it approaches, it's losing height, so kinetic energy is at its maximum, potential energy is at its minimum. Then as it starts to climb again, no kinetic energy, maximum gravitational potential energy. And you're right, oh gosh. Oy. She waits until she gets at her highest kinetic energy and lets go of that rope or loses her grip or whatever. It just looks painful. But oh gosh, one more time. Ow, ow, oh. He's horrible. All right. Other energy transformations. In this case right here, we're going from chemical energy to light energy and heat energy. Okay, here we go. I'm going to heat it up down in there. And you can see it's transforming. It's changing colors. It's pretty cool. You can see the heat coming off of it. And this jar they have it in is made out of rock. And they usually will melt rocks in that. I'm not sure what they're melting, but it's pretty cool looking. Pretty cool looking. The effect of friction. Watch this guy. He has a wire. He heats up the wire to where it's hot enough to start a fire, and there you go. Watch again. Boom. Awesome. He's heating up that wire, puts it down there, and boom, there's your fire. All right. Energy transformation. He ate some food. He has chemical energy in the bonds of the food he ate. He's transferring that energy to this wire and causing the friction, causing friction to heat it up. That transfer of energy from him to the wire, and then they put the wire down on these, and boom, fire. That is a transfer of chemical energy to the energy of friction and heat to light and heat. Pretty cool. Here's some electrical energy. I don't know what kind of gun that is. I just want one. You imagine getting hit with that? Looks like some sort of a taser or something. I don't know. But it's sweet nonetheless. Transferring chemical potential energy. Two different chemicals being mixed causes a glowing. So it's going from chemical potential to light energy. Hard to tell whether or not it's hot or cold reaction, but nonetheless, I think this is awesome looking. Power, work and power. W equals the force times the distance. Looks the same old equation we've been using. Okay. W equals FD, and then power equals work divided by the time over the work, which the work is done. All right. And then they combine the equation. You can just take FD and put it above T. It's the same thing because W equals FD. Doesn't matter if you have force and distance here or work. It's all the same. And here's a little power for you. Ouch. Boom. A little bit of power. A little bit of power. Ooh. Energy conversions in your body. So the food we eat, our body stores as fat or energy. Okay, and we use that energy for our daily routines. Moving, running, thinking. If you don't have enough nutrition, you don't have enough energy, you can't think right. Your mind won't work right. Your body doesn't function properly. We have to have those that chemical potential energy in our body to keep us going. All right. Here's a little Dr. J using energy. So Dr. J is slam dunking the ball. He's doing that from the energy he received from the food he ate. Okay. Quick energy, candy bars. You see those Snickers commercials. All right. That gives you quick energy. If you eat a better meal or a larger meal, like a salad or a steak or burger or something, that gives you energy over a longer period of time. Whereas candy and stuff like that gives you quick energy. You burn it quick. So that's it. I hope these notes help you.